Vitamin B1, or thiamine, often associated with energy metabolism and nerve function, plays a foundational role in the architecture of autophagy, specifically by supporting the mitochondria, the cell's primary energy generators. Autophagy is not a passive or automatic process. It is a highly coordinated, energy-demanding system that requires the active construction of autophagosomes, the trafficking of cellular components, and the fusion of vesicles with lysosomes for degradation. Every step in this chain demands ADP, and mitochondria are central to that energy supply. Thiamine, as a coenzyme in key mitochondrial enzymes such as pyruvate dehydrogenase and alpha-ketoglutarate dehydrogenase, ensures that cells can efficiently convert glucose into usable energy. In this sense, thiamine is not just a participant in metabolism, it is a critical enabler of autophagy itself, allowing the process to unfold with energy precision and cellular confidence. When thiamine is lacking, mitochondrial function falters. ADP production slows, oxidative stress increases, and cells begin to accumulate metabolic waste that they can no longer process or remove effectively. This leads to a paradoxical situation. Even though damaged components are accumulating and autophagy is needed more than ever, the system responsible for cleanup becomes impaired due to lack of energy. Inadequate thiamine thus creates a bottleneck in cellular maintenance, where autophagy may be initiated in response to stress, but stall midway due to energy failure. This contributes not only to cellular dysfunction but also to systemic problems, particularly in tissues with high metabolic demand such as the brain, heart, and muscles. In contrast, when thiamine levels are adequate, mitochondrial efficiency is preserved and autophagy can proceed seamlessly. Cells have enough energy not only to maintain basic function but to invest in long-term upkeep, recycling damaged proteins, clearing defective mitochondria, and preventing the accumulation of cellular debris. This is especially vital during periods of metabolic challenge, such as infections, inflammation, or aging, where the balance between energy supply and cellular stress is easily disrupted. Thiamine helps sustain that balance, ensuring that the energy-intensive work of autophagy can continue even when the cell is under pressure. The brain, which depends heavily on both thiamine and autophagy for clarity and longevity, provides a powerful example of this synergy. Neurons, with their long axons and synaptic complexity, are particularly vulnerable to mitochondrial stress. A shortfall in thiamine can quickly lead to neurological damage, not just from energy failure, but from impaired autophagy that allows toxic proteins or damaged organelles to linger and disrupt function. This may help explain the neurodegenerative patterns seen in thiamine deficiency disorders like Wernicke's encephalopathy or Korsakoff syndrome. On the other hand, adequate thiamine intake supports steady mitochondrial performance and healthy neuronal autophagy, preserving cognitive resilience over time. This relationship between thiamine and autophagy further underscores the importance of everyday nutritional choices. Whole grains, legumes, seeds, and lean meats, rich sources of vitamin B1, can become more than just caloric inputs. They become catalysts of cellular longevity. For individuals following low-carb or highly processed diets, where thiamine-rich foods are often lacking, the risk of subclinical thiamine deficiency may quietly undermine mitochondrial health and compromise autophagic balance. In this context, even a mild insufficiency could impair the body's ability to clean and renew itself at the cellular level. What emerges from this understanding is a hopeful, integrative perspective that by supporting the energetic core of the cell, we also empower its regenerative processes. Thiamine doesn't merely fuel life in a general sense, it enables the machinery of renewal to operate consistently and effectively. In doing so, it allows autophagy to be not just a reaction to stress, but a proactive, ongoing function that maintains cellular quality and systemic resilience. This positions thiamine as a subtle but indispensable contributor to graceful aging and sustained vitality, one that operates at the very intersection of energy, repair, and survival.